Okay, so on today's quest, we're going to do the A and L steps of the goal technique to analyze and learn on the same problems that we did the G and O steps on. Okay, so just to remind you, we had a man riding his bicycle at 8.5 meters per second, so we put that in for V0. He decelerates at negative 2.8 meters per second squared, so we put that in for the acceleration. We said he comes to a stop, so V is 0. And the blue question, we're going to solve for time. The red question, we're going to solve for displacement. And we talked about in the previous video that we're going to use the first equation, V equals V0 plus AT, to solve for the time. Because we know V, we know V0, and we know A, so we just have to rearrange it to solve for the time. So let's do the algebra. That's the A step. V equals V0 plus AT. So V is 0, V0 is 8.5, and A is negative 2.8, and we want to solve for T. Usually, before I put the numbers in, I like to do the algebra. So I'm going to first take the V0 over to the other side, so I'm going to subtract it. V minus V0 equals AT. And so then to get time, I'm going to divide both sides by A. And so we're left with T. Make sure if you're challenged with algebra, go back and do some practice so that you can do the rearranging properly. So T is equal to V minus V0 over A. So I'll go ahead and put the numbers in. So T is equal to V is 0. V0 is 8.5. And A is negative 2.8. And I should be good and put the units in. So the velocity is in meters per second. The acceleration is in meters per second squared. So I'm going to have 0 minus 8.5. So I'm going to get negative 8.5 in the numerator. And negative 2.8 in the denominator. And so if I put that in my calculator, negative over negative will give me a positive. I get 3.04, and if I look at the units meters per second, cancel out, I get 1 over seconds, so that turns out to seconds. All right, so now I've got my number. I've done the A step. Now I do the L step, which is to learn or to look back. Are my units correct? Well, I'm solving for time. I got units of seconds, so that's right. Do I have the right number? Right approximate number? Well, 3 seconds sort of seems reasonable for a time for it to come to rest. If I had 3 million seconds, then I'd probably think I put something in wrong. And then I have to look at the number of significant figures. So I look at the numbers I'm given in the problem. I'm given 2 numbers. 8.5 has 2 significant figures. 2.8 has 2 significant figures. So I need to round my number off to 2 significant figures, so I'm going to write 3.0 seconds as my final number. So now I can go on and do the second part of the problem. So again, populate the numbers. Now I'm going to put in my time, and I'm going to put in the unrounded number for the time. So if I were to put that time into the second equation to solve for the change in position, if I put in 3.0, I'd get a different number to if I put in 3.04. So I need to put in the unrounded number to solve. But for my final answer, I need to round it off to the correct number of significant figures. Okay, so we're going to solve for x minus x0, and we're going to use that equation that I have circled there in red. All right, so let me do the algebra. So I've got v squared equals V0 squared plus 2a times x minus x0. And if there's one equation that students have problems rearranging, it's this equation. So for this equation, I want to get the x minus x0 out of there. So the first thing I have to do is I have to isolate the part of the equation, the 2a x minus x0, that has the thing that I want in it. So that means I have to take that V0 squared over to the other side, and since it's added, I'm going to have to subtract it from both sides. So I'm going to get v squared minus v0 squared is equal to 2a times x minus x0. Okay, so now I want to get the x minus x0. That's what I'm trying to find. How far did he move? So I need to divide both sides by 2a. Okay, so what I have is x minus x0 is equal to v squared minus v0 squared over 2a. And now I'm ready to put my numbers in. If you really are uncomfortable doing this, you can go ahead and put your numbers in earlier and do the rearranging after you've put all your numbers in, whatever works for you. All right, so now I put in my numbers. V is 0. V0 is 8.5 meters per second. I'm going to square that. And then I'm going to divide by 2a. A is minus 2.8 meters per second squared. So I throw in my numbers. I get 12.9. And if I look at the units, I have on the numerator meters squared per second squared divided by meters per second squared. So I left with units of meters. Okay, so now I look back at my number. That's the L step. 12.9 meters. That's probably a reasonable distance. If I had 12 million meters, that would be too much. What do I do for significant figures? Again, I've got two significant figures in the problem, so I need to round this to two significant figures. And so I get 13 meters as my final answer. All right, let's move on to the next problem. So again, remember we had a kangaroo jumping vertically, so let me populate what we had. So it went to a height of 2.4 meters when it's at the top. V is 0 and the acceleration is always minus g. And I'm trying to find the initial velocity and the time. Okay, so we had figured out on the previous video that we're going to use this equation, v squared equals v0 squared minus 2g times y minus y0. And this time we're trying to rearrange this equation to solve for the v0. All right, so let me write it out and we'll do the algebra. Okay, so what am I trying to do now? Now I'm trying to isolate this term. So I'm going to add on. So v squared plus 2g times y minus y0 is equal to v0 squared. And I can just go ahead and put in my numbers. So v is 0. So 0 squared plus 2. Wherever you see a g, you're going to put in positive 9.8 meters per second squared. And y minus y0 is 2.4 meters is equal to v0 squared. So put that into your calculator. Remember, you need to take the square root to get v0. So v0 is equal to the square root of 2 times 9.8 times 2.4. You put that in, you get 6.86. And what are we going to round it off to? Well, we've got the only number we had was 2.4 meters. That's two significant figures. So we're going to round that to 6.9. What are the units? Well, I've got meters per second squared times meters. So that's meters squared per second squared. Take the square root of that, and you get meters per second. So the final speed, the final number for the speed at which it took off, is 6.9 meters per second. All right, last thing, how long does it take to get to the top? We want to solve for the time. So again, put in all the numbers that we have, and I can put in my v0, and again I'm going to put in their unrounded number of 6.86 meters per second and solve for the time. So again, I could use either of these equations. I would rather not use the quadratic formula if I don't have to. So what I'm going to do is I'm going to use that first equation there and solve for the time. So I've got v equals v0 minus gt. and I want to solve for t. So v minus v0 equals minus gt. So t is equal to v minus v0 over negative g. And now I can put in my numbers. I know everything. V is 0. V0 from the previous slide was 6.86. And g is 9.8. And I've got negative g, so I can put negative 9.8. And if I do that, I get 0.6999 seconds. So I would round that to two significant figures, 0.70 seconds. And when you solve these problems, make sure you always round your final answer to significant figures and always include the units. On the test, I'll take off half a point for each time you forget to do significant figures and each time you forget to put in units. Okay, so now you should have all the tools you need to solve the problems for the final quest for this module.